Citizens of Anchorage, Alaska know a lot about cold and ice. They take winter sports very seriously, and ice rinks are among the great attractions. Anchorage leadership faced two converging issues common to many ice rink managers: how to best upgrade their aging athletic center ice rinks, and how to take into account the new EPA regulations that restrict the use of ozone-depleting synthetic chemical refrigerants in their many forms. They needed an environmentally friendly, energy-efficient makeover. They were smart. They sifted through many alternatives and settled on Hillphoenix's expertise to design and oversee a remarkable state-of-the-art system, an ice-friendly, earth-friendly CO2 system. What makes this such an outstanding decision? Of the environmentally friendly solutions available, a CO2 system is the superior choice. Carbon dioxide, CO2, is a naturally occurring component of the atmosphere. It's inexpensive, readily available, non-toxic, and non-flammable. And it doesn't impact the ozone layer, so there are no regulatory issues. We use CO2 that is already in the environment, so no new greenhouse gases are created to use the CO2. Two other benefits of this system are eliminating both water use at the condenser and the toxic chemicals required for water treatment on more traditional systems. The Hillphoenix CO2 refrigeration process uses CO2 as both the natural refrigerant and the fluid circulated under the ice surface from a common liquid receiver. Due to the low viscosity and low pump energy requirements, it's the perfect fluid for an ice surface. An additional benefit to the CO2 direct system is the generous amounts of high-grade heat available for many uses in the facility. CO2 is the most efficient heat transfer fluid to apply to a direct ice system. The Hillphoenix process has no inefficient heat exchanger like traditional chiller systems. Hillphoenix has over 10 years of experience developing the Advansor CO2 system. Follow the CO2 through the system to see how it works.
I'm Tim Henderson. I'm the Industrial Program Manager for Hillphoenix. I've got 25 years experience in the refrigeration industry, and we're here today at the Hillphoenix facility in Conyers, Georgia. The CO2 direct ice rink system that we design and build here in the USA starts with liquid CO2 under the ice surface. We remove heat from the ice surface into the liquid carbon dioxide. We return that back to the refrigeration skid. Once at the skid, any liquid CO2 drops to the bottom of the vessel. Off the top of the vessel, we take the vapor CO2, we compress that. Once we've compressed the CO2 vapor, we go through an oil separation system, remove any oil carryover from the compressors. Now the heated vapor through heated compression, as well as the heat removed from the ice arena system, goes to a heat reclaim system. There we remove any heat we find useful to be used in the arena, be that to heat space, heat water, or even melt ice from the resurfacer. Any heat not used for any of those three operations goes outside and is rejected to the atmosphere. Liquid CO2 returns back to the vessel and is again pumped under the ice surface to remove more heat in this closed loop process.
John Rada is Director of Parks and Recreation for the municipality of Anchorage.
So one of the things I learned over time was trying to find the best management practice as far as maintenance, monitoring energy consumption, making sure we have an environmentally friendly system, and lots of things that I learned over the last 40 years led us to this technology, led us to the conclusion that this is basically a self-contained system. It is low on maintenance. It is driven mostly by computers, big change from my earlier years. But we also have the advantage of remotely monitoring the activities.
The overall performance just in the last 45 days since it was turned on really has shown us that this is the way to go.
Local Anchorage contractor Colin Szymanski took charge of removing the old system and installing the new system.
Hillphoenix gave us everything that a manufacturer could give you. The operators feel this is probably one of the best sheets they've ever dealt with. The water freezes quicker, more even when they're doing the resurfacing, and just overall the operation seems to be running better than they had ever experienced before.
In addition to the advantages of CO2 itself, the mechanics of the system are superb. The design is compact and monitoring is comprehensive. Here's what it looks like in practice. An ergonomic, easy-to-use touchscreen interfaces to the system. It is factory programmed and tested. Variable frequency drives control both the compressors and the CO2 pumps for precise capacity control and energy savings. Compressors are reciprocating and semi-hermetic, which makes them quiet and efficient. They are fitted with vibration dampers, and capacity control ensures precise temperature and ice quality. The CO2 system is a closed system designed for high pressure. It uses up to 90% less pump power compared to traditional systems. The control panel is UL listed and custom manufactured. A two-stage factory-piped self-contained heat reclamation system with a glycol pump can use waste or reclaimed heat for space heat, so the locker room, showers, soccer fields, and other parts of the facility feel a direct benefit. Efficient coalescence oil separators and an oil reservoir provide efficient oil separation and a clean system, while the large reservoir capacity adds to lower seasonal maintenance. The large capacity CO2 liquid holding receiver holds the entire system's charge of refrigerant. The gas cooling system is energy efficient and uses ultra-quiet and efficient variable speed fans. The copper tube aluminum fin surface provides excellent heat transfer. It is direct air cooled, so there's no expensive water usage and no expensive water treatment chemicals. And it's easy to clean and maintain.
But the bottom line is that we think the system that's being provided, being installed, currently in operation at the McDonald Center gives us the best of the new technology, longevity, low maintenance cost, energy savings, and I think we're going to be very satisfied with our selection.
Hill Phoenix CO2, best for the ice rink, best for the environment, inside and out.